Black holes are dense regions of space, and even photons of light cannot overcome the gravitational attraction of these regions. After all, the denser the object, the stronger its gravity. The boundary of a black hole is called the event horizon, and what happens inside remains a mystery to all the scientists and astronomers of the world. But have you ever wondered, what if our planet finds itself next to such a monster? In this video, we'll try to simulate such a situation. In the hypothetical reality, suppose that a black hole did make its way inside the lunar orbit. What then? The first effect would be similar to the one that would occur when a natural satellite approaches a planet. It would begin to change its shape into an elongated one toward the approaching mass. The difference is that in the case of a black hole, everything will happen very quickly. It will naturally tear off the Earth's atmosphere and water. All loose objects will rush into space, followed by trees, soil, mountains, houses, and so on. The planet's innards, heated by the deformation, will be pulled along after the one that has already flown away. All matter will turn into ionized gas, which will flow into the accretion disk. But even there, it will not last long. Within a short time, the black hole will absorb the remains, probably followed by a short burst of hard radiation, which in a million or so years will be recorded by alien astronomers, says Jonathan Zarek. By the way, an accretion disk also appears around stars about to be born, but it usually generates less intense radiation. The friction is low. There's a hypothesis that in the case of a fast approach to a black hole, a phenomenon called spaghettification may appear. The term is a good indication of what's looming. Objects near the event horizon, where strange things happen to time and space, will begin to stretch toward the huge mass, turning into long macarons of subatomic particles. No matter which side your body begins to stretch, your head or your feet, it will happen precipitously. Although you don't have to look for a black hole to experience this effect. You can find any other cosmic object with a large mass. A neutron star will do. There's a sound opinion that spaghettification is a characteristic state of being near a black hole, and the object or subject, having left the event horizon, will probably come out from the other side and return to its former shape. But there's an argument against this theory that at such stretching, any object turns in the end into a stream of particles, and there's no chance to be reborn. And finally, supposedly, there's a dependence between the probability of spaghettification of a person and the size of a black hole. The lesser the mass of the hole, the higher the probability to be stretched out for a couple of hundreds of kilometers. That is, when encountering a supermassive black hole, the astronaut will survive. Since the beginning of the event horizon is far away from the singularity inside, and there'll be no difference between the forces pulling the head and legs. Well, if you want to learn something new about space every day, then go to our channel.